4.1.1, we have to evaluate the integral of sine of 1 over x divided by x squared dx. We can choose to rewrite our integral as sine of 1 over x multiplied by 1 over x squared dx. And if we were to let u equal 1 over x, we'll get something which is close to 1 over x squared when we differentiate the 1 over x. So we let u equal 1 over x, and this can be rewritten as x to the power negative 1. So we differentiate u with respect to x. Differentiating x to the power negative 1, we get negative 1 multiplied by x to the power negative 2. We multiply both sides by dx, and du will be equal to negative x to the power negative 2 dx. Du is equals to 1 over, we write the x to the power negative 2 as 1 over x squared dx. We have 1 over x squared dx there without the negative sign, so let's try to mirror this. Based on that, we multiply both sides by negative, and the negative du will be equals to 1 over x squared dx. So in the place of 1 over x squared dx, we'll substitute negative du. So our integral sine of 1 over x will be substituted with u, and 1 over x squared will be substituted with negative du. We choose to write the negative out of the integral. Integrating sin u, we get negative cos u plus c. Negative multiplied by negative will be positive cos of u, but our u is equals to 1 over x plus c, and we have this as our final answer. 4.1.2, we have to evaluate the integral of 2x cubed minus 11x squared minus 9x plus 10 all divided by 2x minus 1 dx. And to evaluate this integral, we have to use long division, where we divide 2x cubed minus 11x squared minus 9x plus 10 with 2x minus 1. 2x cubed divided by 2x is equals to x squared. X squared multiplied by 2x is equals to 2x cubed. X squared multiplied by negative 1 is equals to negative x squared. 2x cubed minus 2x cubed is equals to 0. Negative 11x squared minus x squared is equals to negative 10x squared. We take that negative 9x, we take it down. Negative 10x squared divided by 2x is equals to negative 5x. Negative 5x multiplied by 2x is equals to negative 10x squared. Negative 5x multiplied by negative 1 is equals to positive 5x. Negative 10x squared minus negative 10x squared is equals to 0. Negative 9x minus positive 5x is equals to negative 14x. We take down that positive 10. Negative 14x divided by 2x is equals to negative 7. Negative 7 multiplied by 2x is equals to negative 14x. Negative 7 multiplied by negative 1 is equals to positive 7. Negative 14x minus negative 14x is equals to 0. 10 minus 7. 10 minus 7 is equals to 3. And this 3 is not paired with any x because it doesn't have an x. We take it up, it's a positive 3, so positive 3 over that, which is 2x minus 1. So instead of integrating that, we integrate that. Standard integration, integrating x squared is equals to x cubed over 3. Integrating 5x, we get 5x squared over 2. Integrating negative 7x, negative 7, we get negative 7x. And integrating 3 over 2x minus 1, we get 3 over ln of 2x minus 1 plus c. But if we were to differentiate this, we are going to use the chain rule inside this parenthesis and multiply this whole thing by 2. But because we are integrating, we will be dividing by 2. And this will be 4.1.3. We have to evaluate the integral of x squared multiplied by e to the power 5x dx. And as you can see, we have a product of two distinct functions, x squared and e to the power 5x. When we differentiate e to the power 5x, we don't get anything remotely close to x squared. And when we differentiate x squared, we don't get anything closer to e to the power 5x. So we can't use the u substitution method. We have to use integration by parts, where the integral of u dv is equals to u multiplied by v minus the integral of v du, or the other formula, integral of f of x multiplied by g prime of x dx is equals to f of x multiplied by g of x minus the integral of g of x multiplied by f prime of x dx. We have to determine the value of u if you are using that method, or f of x if you are using that method, and the value of dv if you are using that method. And if you are using that method, it's going to be g prime of x instead of dv. So we know that this is an algebraic function, the x squared is an algebraic function, and the e to the power 5x is an exponential function. To determine the value of u, we use the Euler rule. With the Euler rule, we know that the first one that we come across going to the right will be equals to u. The algebraic function comes before the exponential function, so the algebraic function will be equals to u, and we say that x squared is an algebraic function, and the other one, e to the power 5x, the exponential function, will be equals to dv. So that squared multiplied by this exponential function is telling us that we have to use integration by parts twice. If x to the power 4 multiplied by sine x or cos x, we are going to use integration by parts 4 times because of that x to the power 4. And now because of this squared that is on top of this x, we have to use integration by parts twice. So instead of using the traditional integration method that we know, where we have to use integration by parts twice, let's use the tabulated integration by parts method. So we'll have u dv. We know that our u is x squared, and the dv is e to the power 5x. With the u, we differentiate the x squared. Differentiating x squared, we get 2x. Differentiating 2x, we get 2. Differentiating 2, we get 0. This side we integrate. When we integrate e to the power 5x, we get e to the power 5x divided by 5. When we integrate e to the power 5x divided by 5, we get e to the power 5x divided by 5, which is 25. We have to again integrate e to the power 5x divided by 25, and we'll get e to the power 5x divided by 5 multiplied by 25, which is 125. So with this method, we start with positive there, negative here, plus minus plus minus, so positive negative, and that integral will be equals to x squared multiplied by e to the power 5x divided by 5. So we are crossing, and we'll also cross here, and we cross here. This side we don't cross, we go horizontally. So x squared multiplied by e to the power 5x over 5 we take this sign, we put it here, and then we are crossing again. 2x multiplied by e to the power 2x multiplied by e to the power 5x over 25. We take this sign, we put it there. 2 multiplied by e to the power 5x over 25 over 125, plus, since we are going horizontally, we'll have the integral of this multiplied by that of 0 multiplied by e to the power 5x over 125 dx, and that 0 will nullify this whole thing. So 0 multiplied by that whole thing will be 0. So that integral will be cancelled. So our answer will be equals to that. So instead of using integration by parts twice, we use this tabulated integration by parts method. For 1.4, we have to evaluate the integral of sin cube x divided by cos cube x dx. One of the methods that you can evaluate this integral is by breaking down the sin cube x as sin squared x multiplied by sin x divided by cos cube x dx. We know that sin squared x plus cos squared x is equals to 1. When you make sin squared x the subject of the formula, we get that sin squared x is equals to 1 minus cos squared x. So instead of sin squared x here, we will substitute 1 minus cos squared x. We keep that sin x. And from here, we let u equal cos x. When we differentiate u with respect to x, we get that when we differentiate cos x, we get negative sin x. We multiply both sides by dx, so du will be equals to negative sin x dx. We have sin x dx there without the negative sign, so let's multiply both sides by -1. Negative du will be equals to sin x dx. So instead of this sin x dx, we'll substitute negative du, because negative du is equals to sin x dx. So in the place of cos, we substitute u, but that cos is squared, so we also square our u. In the place of cos, in the denominator, we substitute u, but that cos in the denominator is cubed, so we also cube the u. And in the place of sin x dx, we said that we'll substitute negative du. This will be equals to, so let's choose to take this negative out of the integral. And from here, we know that if we had a minus b over c, this will be the same as a over c minus b over c. So we get negative 1 over u cube minus u squared over u cube du. We can choose to rewrite that 1 over u cube as u to the power -3, and that square will cancel one of the square there, then we'll be left with 1. So we'll have -1 over u du. So when we integrate u to the power -3, we get u to the power -2 over -2. We integrate 1 over u, we get ln u plus c And let's distribute this negative sign inside the parentheses. This negative multiplied by this negative will be positive, and this negative multiplied by this negative will also be positive. So we'll be left with u to the power negative 2 over 2 plus ln u plus c. U to the power negative 2 can be rewritten as the u to the power negative 2 can be rewritten as u to 1 over u squared plus ln u plus c. So we said that u is equals to cos. We said that u is equals to cos x. So in the place of u, we substitute that cos, but that u is squared, so we also square the cos plus ln of cos, not sine, cos x plus c, and we have this as our final answer. Question 4.2, we have to use partial fractions to determine the integral of 2x minus 3 divided by x squared minus 4x dx. We take out the common factor x. X is our common factor on our denominator. This will be equals to a over x plus b over x minus 4. We divide both sides by x in brackets x minus 4. What we do on the left, we also do on the right. That x into x minus 4 will cancel out with that x into x minus 4. And we'll be left with 2x minus 3 on the left hand side. And we distribute the x into x minus 4 inside the parentheses. That x minus 4 will divide with that x minus 4, and that x will divide with that x. There are two methods that you can use to determine the value of a and b. I will use one method here and use the different method on the August question paper. So the method that you can use here, since we have two unknowns, we set a equal any two numbers. But the easiest numbers that we can pick is x is equals to 4 and x is equals to 0, because when we substitute 4 here, 4 minus 4 will be 0, and 0 multiplied by a will be 0, and that will give us an opportunity to determine the value of b. So we said x is equals to 4 and x is equals to 4 and x is equals to 0. So when we set x is equals to 0 here, 0 multiplied by b will be 0, and we'll have an opportunity to determine the value of a. But you can choose any other two numbers. So when we multiply, so let's first substitute 4 where there is x. We substitute 4 here, 4 minus 4, 0, 0 multiplied by a, 0. 2 multiplied by 4 is 8, 8 minus 3 is 5. We divide both sides by 4, and b will be equals to 5 over 4. So we substitute x is equals to 0 on that equation. 2 multiplied by 0 is 0. We'll be left with negative 3. When we substitute 0 where there is x, 0 minus 4 is equals to minus 4. 0 multiplied by b will be 0. So we divide both sides by minus 4. And a will be equals to negative 3 divided by negative 4, which is 3 over 4. So we have the value of a and the value of b. So our integral b is equals to 5 over 4 divided by x minus 4. This will be equals to, so when we integrate 30 over 4 divided by x, we get 30 over 4 ln x plus, when we integrate 5 over 4 divided by x minus 4, we get 5 over 4 ln of x minus 4. Or you can choose to write the 30 over 4 that side and the 1 over x there and the 5 over 4 there. So you'll integrate 1 over x and multiply it with 3 over 4, and integrate 1 over x minus 4 and multiply it by 5 over 4 plus c.